All right, electrophilic elimination. We just talked about electrophilic addition, so we can also talk about electrophilic elimination, which is just where we will eliminate an electrophile. So let's look at some examples of this. Draw this up. Let's see here. We'll draw all the hydrogens in. Now we just need some base to come in. And in some cases this could be water. Well, let's talk about that in a second actually. We'll just have an electrophile leave. The way I'm going to draw this isn't going to be particularly favorable. We'll probably have some help with pulling off this proton somehow from either solvent or a base or something, but here's the mechanism. We'll just simplify this down. We're going to eliminate an electrophile. There's H plus or protons. It's a very good electrophile. And since we have an elimination reaction, we'll form a double bond species. So see H2 here. That's a 2. So we've eliminated an electrophile. Now, here's another reaction. Well, before we get over to another reaction, it really isn't going to happen this way. Realistically, we're going to have some water come in. Work on that proton right here, and what will end up over here is still an electrophile, but it's a little bit more realistic. So you'll often see steps like this, and sometimes you're like, oh, where's the water coming from? Well, often it's the solvent, or you might have some other solvent. It might not be water, but I'm just using that as an illustration. Okay, so back to electrophile elimination. Let's go back to the nitro group that we had before. So before I had NO2 here, and I had a positive charge here. Now I'm going to go ahead and draw in the proton that exists there. We have a positive charge, and we have, let's see here, we're going to have a double bond here and here still. Now, and let's go ahead and draw in the proton that's there as well. So let's have this leave. So we'll draw that proton's electrons go into the carbon-carbon bond here. And we're going to generate our aromatic ring back. And we've eliminated electrophile again, which is H+. And again, we could have water coming in, helping this proton to leave, helping to stabilize this proton. But, regenerating this aromatic ring is going to help with stability too. Anyway, point being, we've eliminated an electrophile. And that's one of our mechanisms steps that we should look at.